Uh, Good morning, dear student. We are going to learn here the Gondwana University's syllabus for BSc third sem, that is thermal physics. And in this thermal physics, we are going to learn here the 4 unit of this first paper, that is thermal physics. The unit first, it is the kinetic theory of gases and the transport phenomena. In this unit, you are going to learn here the assumptions of the kinetic theory of gases and the pressure exerted by the gas on the wall of the container. Again, in this unit, you have to learn the derivation of this Maxwell law, the distribution of the velocity and its experimental verification. Means by the Maxwell law, we are to be in a state to determine the velocity of the gaseous molecule when they are to be kept in a container. As well as in this unit again, you have to learn that is the degree of freedom. Means this degree of freedom is nothing but the number of independent variable that is required to define the position and orientation of the system. In this degree of freedom, we will have the 3 types of gases, that is monoatomic gas, diatomic gas, and the polyatomic gas. According to that, you should have to require the different number of degree of freedom to define that system and its orientation. Again, in this unit, you will have to learn the laws of the equipartition of energy. Means how energy it is to be distributed in a different layer of the gas. Again, the mean free path and the free path. Again, the expression for the mean free path and on which factor this mean free path it is to be depends, whether it is the temperature or pressure. Means this mean free path, it is directly proportional to the square root of the temperature and inversely proportional to the pressure. Again, in this unit, you have to learn the transport phenomena. That is how this gas it is to be moving from one place to the another place. That in the transport phenomena, you will have to learn the viscosity of the gas, conductivity of the gas, thermal conductivity, as well as the relation between the thermal conductivity and the viscosity, as well as the diffusion of this gas. That is to be learned in the first unit. The another unit of the same paper, that is thermal physics, it is the concept of thermodynamics. Now, the thermodynamics is the branch of physics which deals with the study of heat into the mechanical work. Means how the heat will get converted into the mechanical work and the mechanical work is converted to the heat. Now, to define that, we will have the need of this thermodynamic variable. They are of 2 types, that is intensive as well as extensive. Again, while studying this thermodynamic system, the thermodynamic equilibrium, the thermodynamic process, again, that is the isothermal process, adiabatic process, isochoric process, and a isobaric process. On the basis of that, there is one thermodynamic law that is called to be zeroth law of the thermodynamics, and it will have some importance in a branch of the thermodynamics. Again, in this unit, you will have to learn the concept of the internal energy as well as the first law of the thermodynamics, which contain the part of this internal energy and its applications and the limitation. Derivation of this work done during the isothermal and adiabatic process. In adiabatic relations between this pressure, volume, and temperature, specific heat of this definition of the specific heat and the general relations between the 2 specific heat, that is the specific heat at constant pressure and the specific heat at constant volume. The thermal expansion and the compressibility of this gas, it is to be studied in this second unit. In the third unit, you will have to learn the reversible as well as the irreversible process. means which type of process we call it to be reversible and which type of process we call to be irreversible. As well as in this unit, you will have to learn the second law of thermodynamics, that is statement only, the heat engine and its efficiency, and the Carnot ideal heat engine, which can tells you regarding how the energy it will get converted into 100%, or the some of the engines they will have the less than 100% work out. The Carnot theorem will only the statement in this syllabus. The concept of entropy, the second law of thermodynamics. In terms of the entropy changes in the reversible and irreversible process, as well as the TS diagram and the derivative of the work done and the efficiency. Again, in this unit, that is third unit, you will have to learn the third law of thermodynamics. Now the last but not the least unit, that is the fourth unit. In this fourth unit, you should have to learn the thermodynamic function. There are various thermodynamics functions like internal energy function, enthalpy function, Gibbs function, Helmholtz function, derivation of the Maxwell thermodynamics relation, first and second TDS equation. Again, in this unit, you will have to learn the latent heat. The first latent heat equation, that is Clausius-Clapeyron equation, and the second latent heat, that is second latent heat equation, that is Clausius-Clapeyron equation. Again, in this unit, you will have to learn the Joule-Thomson effect on the porous plug experiment and its application to the enthalpy constant. This is the syllabus of this thermal physics. Now the course outcome of this thermal physics: to understand the kinetic theory of gases, to know about the monoatomic, diatomic, and polyatomic gases, to understand the concept of the thermodynamics law of thermodynamics, that is zeroth law, first law, second law, and third law of the thermodynamics, to understand the concept of the entropy, how the entropy it is to be increase or decrease of the any system. Later on, to understand the Clausius-Clapeyron equation, that is Joule-Thomson effect and the porous plug experiment and its application. Next one, that is develop the skill to solve the numerical problem on the above topics. The last course outcome is to acquire the foundation for the advanced course in physics. And thank you.